Learning more about the eclipse over the past couple weeks as this event has been coming up, and now I want to share with you a pretty cool lesson that I got last week from Gonzaga. I spoke to their science outreach coordinator, and essentially he was telling me that we here on Earth have a very specific relationship with our moon and the sun, and it means that standing on Earth is really the only place in our solar system that something like this can even happen. You call our planet the Goldilocks of the solar system. What does that mean?
Most people probably know the moon and the Earth and the sun are just vastly different sizes. So we're in the Goldilocks zone, and what I say is because the moon's at just the right distance from the Earth and the Earth is at just the right distance from the sun for this kind of total eclipse to happen. On Mars, for example, Mars has 2 moons, but the moons relative to where they are to the sun and to the planet are significantly smaller than the sun. So if Mars were to have a solar eclipse, the moon would only cover about 1/6 of what they see in the sun. If you go a little further out, if you go to Jupiter or Saturn, they have lots of moons, and some of those moons will cause a total solar eclipse, but the thing to remember is that Jupiter and Saturn and Neptune are gas planets, so we wouldn't be able to stand on them. So the idea is that we're just a nice, livable, rocky planet which we can stand on like we are right now, and also see this solar eclipse that's going to happen pretty perfectly if you're within the path of totality.
So you brought these nifty little props for a little exercise in perspective.
So we have this nice little blow up Earth, which the radius of the diameter of this is 8 inches. So this is an 8-inch Earth. That means every inch equals 1,595 kilometers. This little styrofoam ball is roughly the size of the moon in this scaled model system. So this is about 2.1 inches, and the relation between this styrofoam ball and the Earth is actually the same size relation as the actual Earth and moon. So now the next thing we usually want to talk about is how far away the sun and the Earth and moon are from each other. And what I do with students is I have them kind of hold this Earth, and then I ask them, okay, so how far do you think the moon is? If you want to walk back about a little bit.
All right. We figured it was 20 feet,
About 20 feet. So in actuality, using this scale model, if the Earth is 8 inches diameter and the moon's about 2.1 inches, the distance between these two is actually about 20 feet. So it's right where Rob is right now. The sun's diameter is 1.39 million kilometers. So it's much, much, much bigger, but it's also 150 million kilometers away from the Earth. The sun in this scale model is about 1.48, 1.49 miles away from here, and the sun's diameter will be 78 feet.
All right, so let's put that in perspective. I'm the moon, he's the Earth, we're at Gonzaga, then the sun would be all the way over here in Woolton Park. Makes you feel pretty small, huh?
And that's not a bad thing. I think it gives perspective to life, to understanding, and I think it's a good thing to have perspective that we're on a planet, we're a small part on a planet revolving around a giant ball of burning gas in a larger solar system, in a larger galaxy. I mean, it can make you feel small, but it can make you feel like you're part of something huge and, you know, universal and almost infinite.